Okay, so we are done with the derivation. I wanted to tell you that if you go and actually just try to solve these equations, you will arrive at these equations that come from the determinant. So nothing magical happened. I've just represented, solved that system of algebraic equations in a nice shorthand way. But I don't want to run over time, so you're going to have to take my word for that. Or if you're especially curious, you're going to have to go back and solve those equations for yourself. What I need you to do right now is go ahead and take all this right here and make a big note for yourself that those are equations you're going to use from now on. And I'm going to write them again on the slide right here so that I told you this is when you start taking notes, so this is when you write them down. So what we've determined is that to solve y sub p double prime plus p y sub p prime plus q y sub p equal to sum f, where p, q, and f are all functions of x, we just follow these simple steps. We say that y sub p is equal to u1 y1 plus u2 y2. We find y1 y2 from solving y double prime plus py prime plus qy equal to 0. And then we find u1, u2 from the equations u1 prime equal to minus y2f over y1, y2 prime minus y1 prime, y2, u2 prime equal to y1f over y1, y2 prime minus y1 prime, y2. And then we just integrate u1 equal to the integral of u1 prime with respect to x, and u2 equal to the integral of u2 prime with respect to x. And sort of our big takeaway in the end would be that general solutions are going to be y equal to c1 y1 plus c2 y2 plus y sub p, which is just going to be u1 y1 plus u2 y2. Maybe I'll put that in parentheses, since I said this is about finding the particular solution. So this is the thing that you have to remember for solving variation of parameters problems. You don't have to do this derivation to get to this point on your own. That would be a lot of work for every single problem. I wanted you to see the derivation because these tools hopefully are starting to feel like we do the same couple things over and over again, because we really do. It just feels like this disparate jumble of different methods because we clean them up for a nice application each time. So the thing that you should know to yourself is that if you need to solve a non-homogeneous second order differential equation, you're going to have to solve your homogeneous second order differential equation. And then you're just going to have to assume that the particular solution is a combination of u1 times one solution plus u2 times the other solution. Just compute these quantities real easy with derivatives and differences and products and stuff, and then integrate to get u1 and u2. And that's all that this method comes down to. So from here, what we're going to do is just work on a bunch of examples, but I don't want to run any videos too long. So I'm going to go ahead and stop here, and the next video will be your first example.